Hey explorers, today we're studying types of light and its different properties. Natural light sources include stars like our sun, fire, and electricity in storms. There are even some animals and plants that can create their own light, like fireflies, jellyfish, or mushrooms. This is called bioluminescence. Artificial light is created by humans. Our primary source of light on Earth is our sun, a nuclear fireball spewing energy in all directions. The light that we see is simply the one part of the energy that the sun makes that our eyes can detect. Light is waves of electromagnetic radiant energy that we can see with our eyes, even though we only see a small portion of it called the visible light spectrum. We feel it as heat energy and we see it reflected off everything around us. There are even invisible lights such as infrared or ultraviolet, plus there's also radio waves, microwaves, and gamma rays. Now that we've talked about types of light, let's discuss some of the properties of light. Light travels in a straight path. Light can be reflected. Light can be absorbed. Light refracts or bends when passing from one medium into another. White light is made up of many colors. Light diffracts, bends and spreads out when passing through an opening. The experiment we're going to do today shows us how we can bend light using refraction. Have you ever thought about how long it takes light from the sun to reach the Earth? It's not instantaneous, though it might as well be because we're so close. Light actually has to travel at what we call light speed, a term you may have heard before. A great way to think about light speed is to look up at the night sky. Even the closest stars, Alpha Centauri A and B, are 4.35 light years away, which is about 41.32 trillion kilometers. You could travel back and forth to our sun 138,101 times before you reach Alpha Centauri. The stars being 4.35 light years away means that light from their stars takes 4.35 years to reach us. In fact, some of the furthest stars that you can see when you look up at the sky are thousands of light years away. This means they could have burned out long ago, but because their light is still traveling towards us, we're only observing them now from this great distance.
Wow!
Light travels in a straight path when it's not being refracted. When light hits a person or object, it will stop and then bounce off in a new direction, which means that light doesn't reach the area behind the person or object, which is where we get shadows. Have you ever thought about the fact that light from our sun travels 93 million miles just to be blocked by you? Have you ever looked around after a rainstorm and seen a rainbow? These are actually a great representation of light being refracted through tiny droplets of water in the air after the storm. The light bends through the mist and becomes a representation of the entire light spectrum that we can see, separated into the different wavelengths or colors. In today's experiment, we're going to bend light by refracting it through a glass of water and changing an image behind it. This is similar to how eyeglasses work, bending light in just the right way to help somebody see better. For today's experiment, the materials you'll need are a glass with water, markers or something to draw with, and paper or cardboard. We're going to start by drawing two fish on our pieces of paper, one on top of the other, facing the same direction. I almost forgot I had googly eyes. And there. Now there's some proper fish. Now that we have our fish, it's time to place our glass. It's important that the fish and you are on opposite sides of the glass and equal distances apart. So we'll place our big glass full of water, and I've got a second beaker that I'm going to place on this side so we can put our fish against it. So now we can introduce our fish, which start out facing to the left. But because of the way that the light bends on the way in and out of our glass of water, we'll see them flip from the left to the right. And you can even find the point where the refraction happens by moving your fish drying closer to your glass of water. And there we have it, a simple way to be able to experiment with one of the properties of light. For more explorations into the universe around us, subscribe to Clayton's Exploration Station on YouTube and social media. Plus, if you have any questions or experiments you'd like us to try, you can email us at info@explorationstation.net. The future's bright, so you stay curious, explorers.
Clayton's Exploration Station.